You need to have your times tables down by middle school.
Yeah.
But you don't do that by taking the times, and it might be maybe a misinterpretation. Let's say it was a misinterpretation. You need to have your times tables down by the end of grade 4, 5. You need to have them with a 3-second recall. But you don't do that by taking home a times table sheet and staring at it and hoping to God it goes into your brain. So how we teach multiplication, and we will do multiplication later, how we teach multiplication in elementary school is that we do it all through modeling, right? In grade 3, there should be no fact recall at all. It's all just building and understanding what multiplication means. So we do a whole lot of meaning. And then in grade 4, we do a systematic way of learning our timetables. So we start with the doubles, because we've learned the doubles by adding, and we have visuals like, if I take the wheels on 2 cars, I know 2 times 4 is 8, right? And so it's all about visualizing, or like looking at some of the dot arrangements that we had. You can see 8 is 2 sets of 4, 6 is 2 sets of 3, and something like that. Yeah?
I was actually just going to ask you about that. I was in grade 2 when we were doing doubles, adding doubles. And I mean, they had a song to go with it, like doubles, everything. But it was like 2 feet, 4 for a car, 6 for a bug, 8 for a spider, 10. But isn't that still memorizing? Like
it is, but it's visualizing, and it's all pieces. It's all pieces of it, right? So what we do is we actually start by building. So by the time we're ready for in grade 2 to remember, I'm not going to use the word memorize, but to remember quickly the doubles, we're referencing visuals. There's some fixed visuals that they have in the mental math book. I actually much prefer for kids to create their own visuals, because they might like triangles versus tricycles, or they might like, like anytime I say, think of something for 2 sets of 4 in Cape Breton, I get 2 4-wheelers, right? Not cars, because most of the kids are like, yeah, 4-wheeling, right? So I like them to have their own visuals so that they're personally meaningful, but I also want them to connect those visuals with dot arrangements and all those things. But we do building in the previous year leading up to the year where we start to want quick recall. So we want the addition facts down by the end of grade 2. I don't really care if they are. They should be down by the end of grade 3. But we want kids to know their addition facts by the end of grade 2 currently. Might be grade 3 in the future. But we want them to do that because they've built them so much that they now have all kinds of visuals, right? So if you look at our 10 frames and stuff that we've been doing, right, I've built, I've built 8 so much that I now see that 5 plus 3 is 8 because I've seen it so many times, right? And so now, when I ask you, what's your strategy for remembering 5 plus 3, you might say, well, I think of the 10 frame, and I see the top row is filled with 5, and then there's 3 more, so that's 8, right? Or you might say, my visual of 8 is 4, 4, and 4, so I know that 2 sets of 4 makes 8, and I remember that from my 10 frames, right? So the idea is that we built all these concepts before we ever ask kids to memorize them or remember them quickly. We do want fact recall. Like, we want our grade 7s to have their mental math facts. We want them to know, like, multiplication facts. But my point is if they know it and they can't build you a model to show it, they don't really know it. So you can have them as fast as you like. That's all they're ever going to be able to do. They're not going to be able to apply it in any real context, right? So while it's important to remember your facts quickly, that's not the most important thing to learn. I have a PhD in math education. I will not win a multiplication bee. I'm slow. Very slow. And sometimes I make mistakes. However, when I look at numbers, I can take them apart in all kinds of interesting and creative ways, and I can apply that in all kinds of interesting and creative contexts. And that, to me, is more important than being able to win the multiplication bee and complete the sheet of questions in the dictionary.
Yeah, no, I agree. That's why, like, I was fine this morning with her, and he was talking, and I was just like, oh,
We do, I mean, there's a frustration level with junior high teachers and that kids are coming in and not having that down, which I don't understand because it is now coming in grade 4 to have them as math facts to 9 by the end of the year. But my argument is that there are too many people doing just that, getting the kids to memorize them. And if they take them home and they memorize them without meaning, they lose them. Like, they don't stick with you unless you attribute some kind of picture or visual or meaning to it. So, or patterning, like making connections. So things like knowing that, you know, if I have, knowing that if I have 4 rows of 5, for example, I could take and cut this in half and move this down here and have 2 rows of 10. And know that 4 times 5 equals 2 times 10. And that's another way, that's having a doubling strategy that we use. So we make relationships with those things. And if kids don't have those relationships, then it starts to fall apart. And that's a relationship we learn like in grade 5. And it's really important to be able to visualize and to be able to explain why these strategies work. Now in the early grades, we're talking about memorizing or remembering, right, our addition facts. But oftentimes what we're doing is referencing these 10-frame models, right? What we really want is for kids to be able to visualize these 10 frames. So just like we were doing with the, just like we were doing with the 9, or with the 10, the orange rod in the Cuisenaire rods, we can visualize making 10 on here. So if I have 4, who's 4's partner to make 10? 6. And if I have 5, who's 5's partner to make 10? 5. And if I have 7, who goes with 7 to make 10? 3. And so those make 10s facts that we want kids to learn, and we often, that's a mental math outcome in grade 1 currently. By the end of grade 1, they should know to make 10s. That comes from this. It doesn't come from taking home a sheet that says 1 plus 9 equals 10, and 2 plus 8 equals 10, and 3 plus 7 equals 10, and so on, right? Our make 10s facts should come from this visual. Because how much less is there to learn, right? If you can just visualize this and see what makes 10, right? It's way easier than 1 plus 9. Oops, I did it wrong. That was supposed to be 8 plus 2. This is supposed to be 9 plus 1. Okay? The problem with sending kids home with something like that, a sheet that has all those facts written out, is they think they're all 10 isolated things they need to remember. Right? And what we want is for them to visualize that 10 frame and be able to tell us all these relationships because they can see them in the 10 frame. See the difference? Right? It makes such a difference if we can just have that visual and I can imagine moving those things around and I can find all those relationships because I know that 10 frame. I have that visual model of a 10 frame and I played with it so much that now I can imagine it in my mind. Yep?
It makes complete sense to me because when we're talking about different learning styles and having all these visual learners, and then that looks way less threatening than looking at all these symbols, right?
Yeah. And a lot of little kids are not at a level of abstraction in their development, or their developmental thinking, to actually remember all this symbolic stuff, because it's very abstract, right? Whereas the 10 frame is a concrete model, and we play with it so much that kids start to visualize it. When they see it, you can say, tell me what 8 looks like, and they'll visualize 8 in the 10 frame, right? Or And then that way, when you start to add things to 9, like we were saying earlier, 9 plus 7, well, I can take 1 from the 7 and make the 9 a 10, and now I can add 10 plus 6, and guess what? That's easy to do. That's 16, right? And that's where the mental math strategies come from. It comes from this visualization. It comes from having a good, solid understanding of what numbers look like in the 10 frame, what they look like in the 5 frame, how they're related to one another, what they look like on the number line, right? Because this foundational stuff is going to be like, it comes up over and over and over and over again, right? Later on, we're going to learn how to add like 98 plus 27. Well, if we had to add 98 plus 27, right? We can think of that, what way?
Just take 2 off 47 to make 100.
Right. So if I can visualize that that's 98 little counters, right? And if I had 2 more, that would be 100 counters, right? Thinking about 10 frames, or even, I visualize this as base 10 blocks, and we'll do that later on next week. We'll be playing with base 10 blocks. So I can say this is 100 plus 25. And that's so much easier. Like, than adding, oh, let's do this. Oh, wait, 27, 7 and 8 is 15. Y, carry your 1, Y, because I said so, 1. Right? I mean, that's what we do. That's what happens most of us, right? I remember I was talking to a friend of mine one day, and he told this story. He's a math educator, and he's retired now, but he was going into this grade 2 classroom. The grade 2 teacher said, oh, you've got to see it. The kids are so good at their 2-digit addition. And she called on this one little girl to go up to the front of the room and do the 2-digit addition. And she was like writing. She would do a question and then turn and look at the class. And then do the next one, turn and look at. She was not only modeling what the teacher did, she was modeling the teacher dance. Like, she was doing the whole, and so 8 and 7 makes 15, and you put the 1 up here, did everyone get that? And the kid had totally modeled the teacher entirely. And it wasn't that she understood what she was doing, she was still doing traditional algorithm and also doing the traditional teaching practice of the teacher. So we want kids to have flexibility, and the flexibility comes from the visualization. We need to do lots of number line work too, because that's also going to help. Does that make sense? Am I ranting and rating? Yeah. You know what? I'll tell you the story of the 10 frame. I was on the math leaders committee. I was a provincial math leader for all the MK schools in Nova Scotia. But I've been a 7 to 12 teacher my whole career. I'm sitting next to my friend Martha Stewart, who is from the Valley, and she's actually like the director of programs or something with Valley Board. But at the time, she was the math leader for Sitting Up with Valley Board. And she is a guru of elementary mathematics. She taught primary to 2 her whole life, loves math, loves P2 math, and so she's talking about 10 frames. And she's like, it's so important, we need to get more of the 10 frames out of the school, and blah, blah. So I finally had to say, Martha, what the hell is 10 frames? Because I didn't know, because I taught grade 7 to 12, right? And so she showed me this, and I was like, it's the greatest thing ever. Why did I never see this before? Why did I not think of this? Right? Why did I never see this before? Because it so helps with the relational understanding of numbers, right? Understanding the relationships between numbers, being able to visualize numbers, break them into pieces that are manageable, seeing those important benchmarks of 5 and 10, and knowing the relationship to those numbers of every other number. And that's going to help us with estimation, and it's going to help us. Wait till we do multiplication on the 10 frame. That's really exciting. That's not for another week or 2. But it's such a great visual, and it really helps kids. And I am a big believer that kids who hated math were visual spatial learners in a linear sequential classroom. And guess what? They probably would have been really great engineers, but nobody taught them the math they needed to know in order to be the engineers